February-March 2024, Paper 2, Variant 2. Question 1, Part A. Bismuth has metallic bonding. Draw a label diagram to show the metallic bonding. Okay. So for this drawing, you need to draw at least 6 particles, the 6 cations, and you must label each of these cation. So to show that, let's say this one is a bismuth ion, so the labeling is important. And of course you need to draw some delocalized electron surrounding this positive cation, and of course you need to label it as well. Part B. Bismuth reduce water to form bismuth oxide, a colorless gas that ignites with pop sounds form. So this one is a redox reaction. So already told you the bismuth oxide is a product, and another product is obviously hydrogen, because it's a pop sound. So now the bismuth is the one that get oxidized to form bismuth oxide, and the water now is reduced to the hydrogen. So this is a redox reaction about. So you need to put this info into this part 1. Construct an equation for the reduction of water by bismuth. So you start with bismuth, after that react with water. So the bismuth will form this bismuth oxide, and water will form hydrogen gas. After that, you just balance it, right? Part 2. Bismuth oxide is a yellow insoluble solid that melts at 1090 Kelvin. So this is a high melting point. It's telling you the structure is a giant structure. So this is the first hint. Second, the molten compound conducts electricity. So which means there are cations and anions inside this compound. So because after is melt, these cation and anion they are freely move and conducts electricity. So means it's telling you is ionic structure or ionic bondings inside. So the question asking, deduce the structure, whether it's a giant or simple, and the bonding of bismuth oxide. So which bonding is it? Is a covalent bonding or ionic bonding, okay, or others? So obviously this is ionic bonding, right? Because I already told you there are cations and anions inside. So you just explain accordingly. Bismuth has a giant ionic structure. Because giant, we have giant ionic, giant metallic, and giant molecular or giant covalent. So in this one, because it's telling you it has cations and anion, so it must be giant ionic structure. Why it has giant ionic structure? Because the melting point is high. And second, what is a bonding? The bonding is ionic bonding, isn't it? So because it's conduct electricity when it's melt, so therefore the bonding must be ionic bonding between the cations and anion. Part C. Bismuth oxide can be used to form this NaBiO3. So this is another compound, and this is the equation. Part 1. Deduce the oxidation number of the bismuth inside this bismuth oxide and this compound. So in the bismuth oxide, because oxygens, there are 3 oxygens there, so it's -2 times 3, so it's -6. The bismuth, therefore, it will be +6/2 because 2 bismuth there. So therefore, the oxidation number of the bismuth in this oxide is positive 3. So it's positive 3. In this compound, actually is negative charge. So we just use this BiO3 negative. So the oxygens, there are 3 oxygens there. So it's negative 6. Overall charge is negative. So the bismuth must be positive 5. So therefore, the oxidation number of bismuth in this compound is positive 5. Part 2. Identify the reducing agent in equation 1. So first you need to know what is a reducing agent about. So reducing agent is the species that get oxidized. Because while it reduces others, so it must release electrons and get oxidized. So in this equation, or in this reaction, so we know that bismuth oxide is the one that get oxidized because its oxidation number increase from positive 3 to positive 5. So since the bismuth oxide now is get oxidized, so therefore we know that the reducing agent, it must be this bismuth oxide. So this is how you identify reducing agent and the oxidizing agent. So again, remember, reducing agent is the one that get oxidized, means its oxidation number increases. Okay, like in this example. Part D. The NaBiO3, so this compound, is an oxidizing agent which is similar to the KMnO4. So figure 1.1 shows the examples of the use of this oxidizing agent. Part 1. Explain the terms oxidizing agent. So oxidizing agent is a substance or a species that gains electrons. And these electrons need to be produced by other species. So I give you one very simple example. When the sodium reacts with the chlorine, so the sodium will get oxidized to form the sodium ion. The chlorine will get reduced to form chloride. So the half equations is this and this. So sodium, after it reacts, so it will form sodium ion, release the electrons. And these electrons is gained by the chlorine, and the chlorine will form chloride. So in this case, we can see that the oxidation number of the sodium is increases from 0 to positive 1. So we know that the sodium now is being oxidized and is release electron, and these electrons now gains by the chlorine. Chlorine oxidation number initially is 0, after that is negative 1. So the chlorine gains the electrons and form chloride, and it get reduced. So we know that now the chlorine is the one that gains electron, and we can say that chlorine is the one that oxidizes sodium to form the sodium ion. So therefore, we know that oxidizing agent, it's always the ones that gains electron. Okay, so this is a definition again. Oxidizing agent, a substance that gains electron. Okay, as easy as this. Part 2. Compound X formed when the methyl but2-ene reacts with the KMnO4. State the essential conditions for this reaction. I show you the equations here, right? Methylbutylene is this one. When the methylbutylene reacts with KNO4, it can form this compound X. So the compound X is this one, the diol. So in order for this alkene or the CC double bond to form diol, so the KMNO4 need to be cold and it must be dilute. So this is the conditions that needed. So when it's dilute means it's telling you it needs some water, isn't it? So therefore, when if let's say the question asking equation, so you should give this equation, because it needs a water together with the oxidizing agent, in this case is the KMNO4, to form the diol. So means this double bond, right, the pi bonds break, and each of these carbons will get OH, so to form this diol. So now again, the essential conditions for this reaction, it must be the KMNO4 in the cold and dilute condition. So it cannot be concentrated and hot. If it's concentrated and hot, then these CC double bonds will break and form others compound. Part 3. Complete table 1.1 to show that what is observed when the Y and Z react separately with all these reagents. So let's start with the first reagent, sodium carbonate. Sodium carbonate most likely it will react with the acid, means H+. So if let's say the compound, the organic compound, has the carboxylic acid, then you will see some like effervescence and so on. So because for the Y and Z, the compound Y is a propanon, is a ketone, and compound Z is the aldehyde, which is ethana. So in these two compounds, it has no carboxylic acid groups, so they don't have it. So therefore, we know that for the Y and Z, when we put these two compounds together with this sodium carbonate, so it will be no reaction, nothing happen. So no reactions, and for the Z also no reaction, because both compound no carboxylic acid in there. So next reagent, alkaline iodine. When you see alkaline iodine, means it's an iodoform test. So you need to relate, or you need to refer to this structure, the methyl ketone. If the compound has the methyl ketone group, then it will form the yellow precipitate, which is the iodoform, CHI3. So in this compound Y and Z, as you can see, so this is the methyl ketone group, right, CH3CO. So therefore, compound Y will give this yellow precipitate, the iodoform. For the Z, even though this is aldehyde, okay, this one is not a methyl ketone group, but this is the methyl ketone. So in ethana, it has the methyl ketone group, so you will still see the yellow precipitate form. So therefore, both Y and Z, they will form yellow precipitate with the alkaline iodine. For the 2,4-DNPH, this one is for the carbonyl group. In your syllabus, the carbonyl groups that will have a positive results with 2,4-DNPH is a ketone and aldehyde. So whenever there is a ketone and aldehyde, it will react with this 2,4-DNPH and form the red precipitate. You can put orange precipitate, it's okay. Because the Y and Z, so this is a ketone and this is aldehyde, and they have the carbonyl group. So both compound will give the red precipitate with the 240 NPH. So that's why you get this answer. So the last reagent is the one that distinguish them, right? Means if we want to know the difference between the Y and Z, so we can use a Fillings reagent or distolens reagent. So because Dolenz reagent is specially for the aldehyde. So whenever you see CHO, right, so this aldehyde, so the it will react with the Dolenz reagent, and it will reduce the silver ion to silver. So for this compound Y, which is a propanol, because this one, right, is just a methyl ketone and no aldehyde group, so therefore it will not react with this Dolenz reagent. For the compound Z, again, because this is aldehyde, so it has these aldehyde groups, so it can react with this Dolenz reagent and reduce the silver ion to silver. Then you see the silver mirror. Part 4. Construct an equations for the reactions of Z. Z means this one. This ethana. Right. So this ethana with the sodium borohydride, the reducing agent. One thing that you have to understand, when you try to give the equation, do not include this sodium borohydride. You just need to use this one to represent the sodium borohydride. So means this is a reducing agent, the H with the square bracket. So let's start with this one. Ethana, you should know the structure, CH3CHO. And this one need to react with the sodium borohydride, means add 2 hydrogen and form ethanol. If you cannot really imagine that, okay, I will show you this one. Ethana, the structure is this. So when it reacts with the sodium borohydride, you need to get reduced. Reduced means adds hydrogen. So means this oxygen will get 1 hydrogen, and this carbon will get 1 hydrogen, so the pi bonds gone. So it will form this ethanol. So means when this ethana is reduced by the sodium borohydride, it needs to add 2 hydrogen at these 2 places. Right, so this is the equation. Part E. Part E. NaBiO3 can be used to determine the concentration of the manganese 2 solution. And the ionic equation is given. So we need to use this equation, especially the mole ratio between these 2 species, to get the answer. A student used the following procedure in an experiment. So first, the student add 100 cm³ of saturated solutions of manganese 2 to a volumetric flask. Okay, something like this. Put 100 cm³ in 1 dm³. Okay, after that, add distilled water, top up to the mark, and the solutions that prepare, we need to take 25 cm³ for titration. So use the 0.1 mole per dm³ of this salt solution, titrate with this manganese 2 solution. So again, 25 cm³ of diluted manganese 2 solution used, which from the preparations just now. And the question now asking, calculate the concentration of the manganese 2 in the saturated solution, means this one. So first, we need to calculate the moles of these salt solutions or salt that use. So we need to use this information. So because in this part already told us that the volume of this NaBiO3 solutions that use is 21.5. So we use this volume and its concentration to find the moles of this solution, or the mole of this compound or this salt. So use the MV over 1000. So the concentration times the volumes, 21.5 over 1000. So you get the mole of this salt. So after that, we need to use the mole ratio. From this equation, because the salt here is 5 mole and the manganese 2 is 2 mole. If we want to find the moles of manganese, so we must use a ratio. And the ratio must be 2 over 5 because it's a smaller ratio. The moles of manganese is lesser than moles of this salt. So therefore, we know that is 2 over 5 times the moles of the salt here. Must use a smaller ratio. Then you will get 8.6 times 10^4 mole. Once you get this mole, then you need to find the concentration of this manganese solution, the diluted manganese 2 solution. So use the mole and the volume. Volume that used is 25 cm cube. Convert to dm cube means 25 over 1000. So then use the mole over this volume. You get 0.0344 mole per dm cube. Because now the question asking the concentration of the saturated solution, so means the solutions that initially used. So because in this part, the concentration here is for the diluted solution, and this solution is diluted or is being diluted 10 times, means from this the concentrated or saturated solution. So means if let's say you want to get the concentration of the saturated solution, you need to use the diluted solutions times 10. Means 0.0344 times 1000 over 100 means times 10. You get the concentration of the saturated manganese 2 solution. So because this solution being diluted 10 times to form this, once you get this concentration, then you can calculate the concentration of this saturated. So just need to times 10. So you get this answer. Okay, that's all. Thank you.